Download this code from codegive.com, link in the description below. Certainly. Binary phase shift keying, BPSK, is a digital modulation technique that conveys data by changing the phase of a reference signal. In the context of an additive white Gaussian noise, AWGN, channel, BPSK is often used because it provides a good balance between performance and complexity. Tutorial on BPSK in an AWGN channel using MATLAB. Step 1. Understanding BPSK. In BPSK, the data bits are represented as two different phases. 0 is represented by a phase of 0 degrees. 1 is represented by a phase of 180 degrees. This means that the transmitted signal can be represented as 4-bit 0, \s, t, equals a \dot cos, 2 \pi f underscore ct, \, 4-bit 1, s, t, equals a \dot cos, 2 \pi f underscore ct, where a is the amplitude of the signal. f underscore c is the carrier frequency. Step 2, BPSK modulation and demodulation. 1. Modulation, the input bit stream is converted into BPSK symbols. 2. Transmission, the symbols are transmitted over the AWGN channel. 3. Reception, the received signal is demodulated to retrieve the original bit stream. Step 3, MATLAB implementation. Here is a simple MATLAB code example to simulate BPSK modulation and demodulation in an AWGN channel. Explanation of the code. 1. Parameters. Number bits, number of bits to transmit. A. Amplitude of the signal. Fc, carrier frequency. Fs, sampling frequency. EBN 0_dB, a range of values for the energy per bit to noise power spectral density ratio. 2. Data generation, random binary data is generated. 3. BPSK modulation, the binary data is converted into BPSK symbols. The waveform is constructed based on the bit values. 4. AWGN channel simulation, noise is added to the transmitted signal based on the specified EB/N0 ratios. 5. Demodulation, the received signal is demodulated by checking the sign of the received waveform. 6. BER calculation, the bit error rate, BER, is calculated based on the difference between transmitted and received data. 7. Plotting, finally, the results are plotted on a semi-logarithmic scale to visualize the BER performance against different levels of noise. Conclusion. This MATLAB tutorial covers the basics of BPSK modulation and demodulation in an AWGN channel. The simulation gives insights into how BPSK performs under different noise conditions, and the resulting BER plot is an essential tool for evaluating communication system performance. You can experiment with different parameters to see how they affect the performance of the BPSK system.